So today we're talking about perpendicular lines. And you recall perpendicular means right angle, intersecting to form a right angle. There's lots of special theorems that go along with perpendicular lines. So first off, the one thing that we want to talk about is if we're finding the distance between a point and a line. So we're looking for what is the distance from this point A, I'll use this, from this point A up here to this line BC down there. It includes BC and D. Which distance would we want to choose? Because I can take any of those, AD, AC, AB, I can find the distance of all of those different segments. Which one is going to be the correct one to choose for the distance? What do you think? Well, the one that would make the most sense is the shortest distance, right? We always want to find the shortest distance because these longer distances, if I were to use them, notice that like if I did AB there, I just want AB. Come on, AB. There we go. If I swung that over, AB it intersects that distance over here again, doesn't it? Okay. So which would be correct? It's kind of tough to say. We want the shortest possible distance. And that shortest possible distance is always the right angle or perpendicular distance. So that doesn't play into what we're doing so much today, but it's an important application of perpendicular because it's going to come into play later on when we're working the coordinate plane. When we're finding the distance between a point and a line, we always want to choose the perpendicular or right angle distance. All right, into the meat of what we're going to learn today. We have three basic theorems we're dealing with this time. First off, the linear pair perpendicular theorem, which is a really long name for something that's really simple to think about. Basically, if two lines intersect to form a linear pair of congruent angles. Well, linear pair means what? They add up to 180, right? And if those angles are congruent, then both of them have to be 90. Because 180 divided by 2 is 90. So if angle 1 and angle 2 here are congruent, that means they have to both be 90, which means that the two lines must be perpendicular. So if you get a linear pair of congruent angles, the lines have to be perpendicular. Theorem 311, the perpendicular transversal theorem. Again, if a transversal is perpendicular to one line, so given the lines are parallel, notice we already know the lines are parallel here. Okay? So we already know that. And the transversal is perpendicular to one line, well, then by corresponding angles, if this is a right angle, this must also be a right angle, so it's perpendicular to the other line as well. Again, kind of obvious. A kind of obvious theorem. But basically, if lines are parallel, if we know they're parallel, then and one is perpendicular, the other one must also be. 312 actually comes into play a little more often. Lines perpendicular to a transversal theorem, basically saying if two lines are perpendicular to the same transversal, two lines both perpendicular to the same transversal, P in this case, then the lines have to be parallel. And we can see that clearly because we can use our alternate or corresponding angles converse. When that gets more interesting is when we have pictures like we had in the review that we just did. And I had the angles not necessarily in what would normally be an angle pair that we deal with. Not every angle pair is named. That particular pair of angles here in this case is not named. If I call this line A and this line B and this line X, okay, I could still say that A is parallel to B without having to do any additional steps because they're both perpendicular to X. I don't need to have corresponding or alternate interior or anything like that if I have right angles. So if I have right angles, that takes away the need for the alternate interior or the corresponding or whatever to show the lines are parallel. If they're both right angles, it's automatically parallel lines. That's great. Now, that seems really simple, but where it gets messed up is when things start getting complicated. So what I'm going to do is give you a couple right angles. You have to tell me which lines are parallel based on where the angles are. So let's say I got a right angle here. I'll clone that one. And let's put another right angle down here. What are my parallel lines in this case? Because there's extra information there. So it can really be helpful is to kind of highlight and say, oh, gosh, well, here's my transversal, and here are the two lines affected by that. Line Q is not involved at all, is it? So line Q is out. Line S is not involved at all, is it? So line S is out. What are my parallel lines? R and P, yeah. Pretty easy to see when we highlight it like that, isn't it? All right, let's undo that. And this time, let's do that one and this one. Now what are my parallel lines? Well, angle T involves these two lines. Angle P involves these two lines. Do I have parallel lines in this picture? Where? Where is one line that has perpendicular, where both lines are perpendicular to the same line? One pair of lines that are perpendicular to the same line. Okay? I mean, S is perpendicular to P, but I don't know if it's perpendicular to R. T is perpendicular to R, but I don't know if it's perpendicular. I don't know if R is perpendicular to S, or if there's a right angle down here. Do I actually have any parallel lines in that particular picture? No. No parallel lines there. See how it gets tricky? You got to really determine where is the one line that is perpendicular to both other lines, where there's the one transversal, and then what are the two lines that are parallel. Okay, let's try again. This time I'm going to go, oh no, don't do that. It split my little right angle figure. That's sad. Okay, that's okay, we make it work. All right, do I have a single transversal this time? A single line that is perpendicular to two lines? Sure. R is perpendicular to both S and T, isn't it? So what are my parallel lines? S and T. And again, the way we would indicate that when we're writing it, we use our symbols. S is parallel to T. Notice our parallel symbol is parallel lines. We'd also could indicate perpendicular by saying R is perpendicular to T. Notice my perpendicular symbol is perpendiculars. Lines. Very exciting, isn't it? The symbols match exactly what it is you're trying to say. Just like the line symbol is a line, and the segment symbol is a segment, and the ray symbol is a ray. Yay! It works. All right. The photo shows a layout of a neighborhood. Which streets, if we call them S Street, T, the streets are S, T, and U. That's a little hard to see. These streets are P and Q. My right angles, in case you can't see them, are here, here, and here. What streets have to be parallel based on that? Well, I have two streets. If this is Q here is a transversal that's perpendicular to both T and S. So T must be parallel to S, right? So how would I say that and explain it? I would say T is parallel to S because both are perpendicular to Q. So that's how to explain it. What else do we have? Well, if I look further, I notice that there are two lines perpendicular to this one. S is perpendicular to both P and Q, so P must be parallel to Q because both are perpendicular to S. Do I know anything about U? Okay, I got T and S, I got P and Q. I don't know anything about U. U Street might be no good at all. Some weird angle. The city engineers did a poor job. Similar picture. Is B parallel to A? Is B parallel to A? Let's take a look. Here's B. Oh, the green highlighter didn't work so well there. Let's try again. Let's try the yellow one. A little better. There's B. There's A. Is there a transversal that is perpendicular to both of them? Which one? D. Okay. Yes. Both perpendicular to D. Okay. We can get away with some sentence fragments here. It's okay. This is math, not English. Is B perpendicular to C? Oh, is B perpendicular to C? It's not indicated, is it? I don't have a right angle symbol there, so it might be quick to say no, but is it? Well, we know that B is parallel to A. Okay, we know B is parallel to A. We got that right here, right? And we know that B is perpendicular to D. So A, or B must be perpendicular to C. Sorry, I'm getting too many letters here. B is parallel to A, and C is perpendicular to A. That's what I needed. C is perpendicular to A. We've got that right there. C is perpendicular to A. So if C is perpendicular to A and B is parallel to A, C must be perpendicular to B. Okay? Because they're both, again, this goes back to perpendicular transversal. If transversal is perpendicular to one of two parallel lines, it's perpendicular to the other line. So that one's a little bit trickier. You have to build all the parallels and perpendiculars up, but in that case, there's enough there to do it. And again, the fact that it's a street picture makes it a little harder to see. With just lines on the plane, it'd be a little bit easier. Okay, that's it. And what do I always say? See you in class.